Let's talk about the question 1. The question is determine an equation for the family of quartic functions with zeros minus 5 of 2, minus 1, 7 of 2 and 3. Let's talk about the part A. A quadric function with zeros a, b, c, and d can be written in the form fx. Where k is a constant, given the 0, minus 5 of 2, minus 1, 7 of 2, and 3, we can write two functions that belong to this family by choosing different values for k. We choose k equals 1 and k equals 2 for the two functions. For k equals 1, we have the function f1x. By expanding this function, we can get the final function. For k equals 2, we have the function f2x. Then, by expanding this function, we can get the final function. Now let's turn to the question B. We can do this substituting the point into the general form of the quadratic function and solving for k. The equation we get is this. By solving this equation, we get k equals minus 20 of 11. Therefore, the equation for the member of the family whose graph passed through the point minus 225 is f3x. By expanding this function, we can get this. Now let's talk about the question C. We need to sketch a graph. I use the decimals to help me. As we can see, this is at the graph of f1x, f2x, and f3x. And I point out each point on the x-rays. Now let's move on to the question 2. The distance d in kilometers traveled by a plane after t hours can be represented by the function dt. For the t is greater than or equal to 0 and less than or equal to 10. How long does the plane take to fly 4,088 kilometers? This is a problem of solving for t when dt equals 4,088. The equation given is a cubic equation, which represents the distance traveled by the plane as a function of time. The coefficients of the equation are likely derived from the physics of the plane's motion, taking into account factors like speed, acceleration, and possibly wind resistance or other factors. To find out how long the plane takes to fly 4,088 kilometers, we need to set dt equals 4,088 and solve for t. Then we can get three roots. but we have the value of t is limited, so we can only choose t equals 7. So the plane takes 7 hours to fly 4,088 kilometers. This means that according to the model given by the equation, the plane will have traveled a distance of 4,088 kilometers 7 hours after it started its journey. Let's talk about the last question. We need to write an equation for a rational function. A rational function is a function can be written as the ratio of two polynomials. The x-intercept in the value of x where the function crosses the x-rays. The y-intercept is the value of the function with x equals 0. A vertical asymptote is a vertical line that the graph of the function approaches but never touch. The equation of a vertical asymptote is the form x equals a, where a is a constant. A horizontal asymptote is a horizontal line that the graph of the function approaches as x goes to infinity or negative infinity. The equation of a horizontal asymptote is of the form y equals b, where b is a constant. Given these features, we can write a rational function that satisfies all these conditions. Let's start by writing a function that has an x-intercept of -4. It means that x plus 4 is a factor in the numerator of the function. Next, we want the function to have a y-intercept of -2. This means that when we plug in x equals 0 into the function, we should get -2. The function also has a vertical asymptote at x equals 2, which means that x minus 2 is a factor in the denominator of the function. Finally, the function has a horizontal asymptote at y equals 1, which means that the degree of the polynomial in the numerator and the denominator must be the same, and the ratio of the leading coefficients must be 1. Let's find a such function. For the equation, we find that for the function to have y-intercept of -2, the coefficients a and b must be equal and non-zero. So we can choose a equals b equals 1 without loss of generality. Therefore, a rational function that satisfies all these conditions is fx, like this. This function has an x-intercept of -4, y-intercept of -2, a vertical asymptote at x equals 2, and a horizontal asymptote at y equals 1. And I graph this equation that I write.